Good evening, Amarendra sir.
Good evening, madam.
Hello.
I am audible, madam?
Uh, the volume is very low, sir. What about other participant? Is the sir is audible to you clearly?
Yes, ma'am.
Very low voice, ma'am.
I am audible.
Okay, sir. Can you start your presentation? Like before that, we'll give a introduction of you, and after that, can you please start your presentation?
Okay.
Tejasvi, ma'am.
Ma'am, I'm available here.
Yeah. You can start introducing sir, ma'am.
Okay, ma'am. Thank you. So, I, Koti Tejasvi from Department of CSE, would like to introduce you all about today's resource person, Dr. Amarendra Singh, sir. Dr. Amarendra Singh Yadav is currently working as an assistant professor at Atal Bihari Vajpayee Indian Institute of Information Technology and Management, Gwalior, India. He received his doctorate from Motilal Nehru National Institute of Technology, Allahabad, Uttar Pradesh. MTech from Madan Mohan Malviya University of Technology, Gorakhpur, Uttar Pradesh. And BTech in Information Technology from State University, Uttar Pradesh, India. His research focuses on improving the scalability of blockchain network, developing use case specific consonance algorithms, and the security of blockchains. His research interest includes blockchain technology, peer-to-peer systems, distributed ledger technology and distributed systems, cloud computing, and computer network. He has published more than 30 research articles in reputed journals like SCI and SCIE index journals and conferences. Dr. Yadav has been an expert speaker in various faculty development programs and has organized a number of conferences, workshops, and short-term courses. With this brief introduction, I once again welcome you, sir.
Thank you, ma'am.
Yeah. Over to you, sir.
Screen is visible.
Yes, sir. The screen is visible, sir.
So, good evening to all of you. Thank you for your invitation. So, this FDP, well, understand correctly, is a blockchain and its application, security analysis. So now this has come into, I call it a fashion in the last 5 to 10 years. But we must understand that as a digital currency. So the first e-cash payment introduced by David Strong. So give it 90s, 80s, early of 80s. So then he implemented in mid 95, around 90s and 95. So but it's also true that the first Bitcoin application of distributed ledger, which is blockchain, come in 2009, and when Satoshi Nakamoto implemented Bitcoin, that can be uh, more powerful for decentralized network using a Bitcoin network. So this is a basic view of blockchain technology, how to introduce. So in this lecture, we have discussed, we have some outlines, what is a blockchain technology, and replication, consensus, definition of blockchain technology, difference between the traditional database and blockchain, working model of blockchain based transactions, generation of blockchain technology, core component of blockchain technology, use of cryptography in blockchain, classification of blockchain, and what is the platform we have used in the blockchain technology, and we need of consensus. Why we need consensus? Why we without consensus blockchain is a nothing, and the security and growth of the blockchain technology and blockchain use cases. So first we have here discuss some just like motivation of the blockchain technology. So why blockchain so popular nowadays? Why just like some politician and actors we have about talking about the blockchain and why on this news of trending. So there are couple of reasons blockchain are very popular. One of that trust, and another second is a decentralization. So trust means they are allowed the other trust various application and they do not to each other. And the second is a decentralization. That means they are allowed to run the application of different application at different platform. But decentralization network the two parts, efficient and cost effective. So these two are very important and enable of new applications, and they also cut out of the middleware and they allow the decentralization of network and nature. So these making application more efficient and possible cost effective. So this is a basic application why we have popular other blockchain trust, and second is a decentralized nature. So there are some lots of example in the using of blockchain technology. Just like we have some grading system, we have just like some mark sheets, we have deployed the server, and some land registry of transformation from one property, transfer from one person to another person, some healthcare issues and supply chain management. And currently we have most trending research topic in the blockchain technology, electric vehicle transaction from air to air and vehicle over internet. So there are lots of research area in the blockchain technology currently. So first we have discussed what is a blockchain. So we have a data structure linked list. So that we have a linked list is a data structure. So that nodes are to link to each other and based on the some memory addresses. But in the blockchain, we have linked the address the block to add the using of the hashes of the particular block. No, not can be memory addresses. So the continuing growing list of record, so called is a block which are linked and secure using cryptography. So based on this concept, only the blockchain. So we have several block and these several block connected to each other, some kind of linked list, but not a based on memory addresses. So here discussing which types of link, it is similar to linked list block are connected to each other. So by some kind of link, so we call the distributed data structure, not a distributed ledger technology. This types of is a distributed data structure. So this is not a formal definition, but I try to incorporate all the different connection and different types of block. We have single line. So have discussed. So a kind of linked list, just the linking of block is not based on the memory address. It is based on the some other links, hashes link, any other of types of link. So and append only distributed ledger, where record are stored in hash link block, and these blocks form a chain. So here we have only discussed some basic definition of the block. So here blockchain is a decentralized computation and information sharing platform that enables multiple authority domains why do trust each other in a rational decision making process. So blockchain is not a particular platform, it is just like application. How to distributed network can be deployed, how to secure the data in the distributed way of manners. So who will be sharing the and that second point is the information sharing platform. So who will be sharing the information? So in the blockchain, multiple authority sharing the information means multiple peer and multiple nodes and multiple machine can share the information in the synchronization way of. So these and another things we have the use of the enables of multiple domains. So these domains do not trust to each other, but maybe for cooperation of coordination and collaboration of they do not trust to each other, but still they want to reach toward rational decision making process. So that means they want to make a correct decision. Hello.
Hello.
Yes, sir. Any problem, sir? Hello.
Yeah, Mr. Ujjwal, any problem is there?
No, ma'am.
Sir, you please mute yourself.
So this is not a basic definition of the blockchain technology. So I will discuss here the basic blockchain technology definition. So blockchain is a distributed database or ledger shared among a computer network nodes. Please mute. So I will only discuss just some basic things of blockchain technology, not a particular definition of the blockchain technology. So the basic definition of the blockchain technology is that distributed database or ledger shared among a computer network nodes. They are best known to their crucial role of cryptocurrency and a digital database ledger that is distributed among the node of a peer-to-peer network. So this is a basic definition of the blockchain network. So distributed blockchain network and blockchain, we have removed the centralized system and then can create a distributed decentralized network. So basically we have discussed here the centralized architecture and decentralized architecture. So centralized architecture is just like a central coordinator system that give order to all. That means they are one network and one leader can be send the message to all our nodes. Then all our nodes we have received the message from through the central coordinator. There a central coordinator system is a fail. A central coordinator is a correct. So all our system is a fail and all our system is a corrupted. So all node are lost connection if central server is a fail. So single failure of system is can remove we are using of the distributed ledger technology. That means blockchain technology. And then can be in the mind of the decentralized architecture. So has several coordinator nodes. All nodes are connected to each other, and all are each coordinated to connected to each other. That means all are node, all are coordinator to connected to each other. If one node is a fail, then the another node is connected to the another nodes. Just that means there are 5 nodes in the network. Node 1 is a fail, and node 1 is a there are some peers nodes, and then after some peer nodes we have connected to the node 2. So the single failure of system can be avoided with using of the decentralized architecture. Their advantage we have used here the decentralized architecture. If coordinator node fail, so individual node can join another coordinator, but system cannot be failed. So work even under few failure. There are some thousands of nodes, there are some 500, 200 nodes that fail, but the another nodes you have connect to the another coordinator, but system is properly working. But in the centralized architecture, if coordinator is a fail, the whole system is a failure and lost the all our connection to the peer nodes. So basic difference between the centralized architecture and the decentralized architecture. So here we have shown that there are 3 types of network in the computer network. First is a centralized network, second is a decentralized network, and third is a distributed network. So centralized network means all the nodes have connected under a single authority. In this figure, we have shown that a single coordinator to connect to all our other connecting peers. There are some small nodes in just like a peer nodes, that means machines and different nodes. If the single coordinator node is a fail, if single authority network is a fail, the whole system is a break. No can be share the information to each other. And next is a decentralized network. Decentralized network is no single authority, several control the nodes, and they all have individual entity. Just like here, 6 node and 6 coordinator in the network, and then all coordinator to connect to each other, and all coordinator have several pairs of nodes. So third is a distributed network. So every node is independent and interconnected with each other. So here there are some nodes, the node in the network and six machines in the network, and these are connected to each other, and all our nodes peer also connected to each other. If these node is a fail, so these peer nodes are connected to the another nodes. So blockchain and distributed ledger technology is based on the distributed network, not as a decentralized network. Blockchain is based on the distributed network. So that means powered by network management software, we have used some kind of application can manage the monitoring and data control, and then combining the allocation network and bandwidth. Then all other things we have access to the core networking processes. But here there are three networks: centralized network, decentralized network, and distributed network. Distributed network can be used in the blockchain technology and can be used on the decentralized distributed ledger technology. So we have here we have next slide we have discussed there some examples. We have how to remove the centralized system, why we remove the centralized system, why we move to the decentralized network, why we use a decentralized and distributed concept. So here in this figure we have shown that information sharing platform. In this figure there Alice and Bob. So just like we have traditional way, we use all the Microsoft Word, MS Office, all our person we have used in the Microsoft Word. So just like Alice and Bob, we have worked in the same project. So Alice, we have update some file in the old records and own MS Office and own Word and own Notepad. That can after we have sent to the Bob, then Bob changes and modification and updation of file. There can be change of some types of data in the file. Then can after we have shared to the Alice. So these traditional way of information, we are sharing the document. Just like Alice, we have some write the information, then share the Bob. And Bob, we have write the information, share to the Alice. So this is a way. That's the disadvantages in this traditional way of information. Alice and Bob simultaneously edit the document, not can synchronize to each other. So this is a problem of the centralized database and traditional way of using of any types of Notepad and Microsoft Word, any PowerPoint, any types of data you can be used, any in the file system, any Office system. So this is a traditional way Microsoft system. Two-person are not able to simultaneously edit and modify and read the document. Next, we have use of the Google Doc file. Another option we have use of the Google Doc file and Google Share and Google Excel sheets. So in this system, Alice send the write the some document and update the document and modify the write of any types of things in the project. We have update the project. So we have sent then after we have saved automatically saved to, and Bob will also will read it and update the file in the same time. So it is shared Google Doc, edit both user, but still here environmental still is a centralized. So this the centralized system is a harm to the humans. So centralized environment therefore susceptible to the single point of failure. That means there are Google server is a fail, the Google server is a busy, there is some most number of hits in the network. So the bottleneck problem can be resolved in the Google shared file. So if the server is a loss, the Google server is a fail, the whole data is a so another failure of the centralized system that can be lost to the humans and harm to the humans documents. Then we have launch and we introduce in the any or we distributed concept. So in this the distributed concept in this mind we have come to the distributed ledger technology. So in this way, in this figure we have shown that there are 2% also Alice and Bob. So has her own copy and Bob has own copy. So they can independently write personal copy. But DLT ensure that whatever is written by both Alice and Bob is getting synchronized with each other, and both is able to see the most updated copy. So in this distributed concept, both can simultaneously read and write and update and delete the file or documents. So in this figure, we not introduced the blockchain concept. We have only introduced the distributed ledger technology concept. So here, this is an ideal solution. So Alice and Bob, we have write the document to each other and then synchronize, then update the file from both of end. So everyone edit the local copy and the maintain the consistency of the global copy. So this is the ideal concept of the we use in the ledger technology. So here we have next slide. We have discussed the multiple domain. Just like there are previous slide only two domains, just like Alice and Bob are two person. But in this there are lots of nodes and lots of person we have connected to each other. So they are in this figure, just like 8 to 9 nodes in the network. So every node we have maintained the local copy of the data and also the global sheet of the data. So if database is a historical information is available, so everyone is a public ledger. So if the data is a historical information is not available, so it is a private network. So but here we have discussed the public ledger. So if just like here node we have update the information, node 1 update the information, then after we have synchronized to node all our rest of node we have same copy of the database and update the information of the own repository and own replica. So local copy is at every node is identical copy, and then also we have update the global copy of the database. So local copy or always update based on the global information. Just like node 1 we have update some another files in another block we have add in the own database. Then after we have broadcast the information to all other nodes, and all other nodes we also the data in our replica copy and based on the global information. So this is a multiple domain example. So we have discussed the some example in the sharing of the data and sharing the some information and coin of the transactions money. So in this figure we have shared the some rational decision making process. So in the basic definition we have discussed in the blockchain technology, just like a decentralized network, sharing platform, and models and multiple domains, and then fourth is a rational decision making process. So here in this figure in this slide we have discussed the decentralized information sharing platform, multiple authority domains, and the rational decision making process. So here we have this rational decision making process. So in this figure, in this slide, we have show that 4%, Alice, Eve, Bob, and John. So here we have Alice is just like a $200 we have on money, on wallet, and Bob also we have stored the Alice information. Alice is the on the 200, and also Eve also store the Alice information 200, and John also update the own copy of local copy based on the global decision. So here that means this ledger is a public ledger, because there all our nodes we have updated the same amount of transaction, Alice $200, Alice 200, and Alice 200, and Alice 200. That means this is a public ledger. Otherwise private ledger only Alice know it is only wallet is at $200. All are Bob, John, and Eve nothing know to Alice amount of currency wallet. So we have here discussed in this figure we have shown that Alice sent the $100 to the Bob. Then after successfully transaction we have received to the Bob, then Bob we have update the block in the own local copy, and then after we have Bob broadcast the nodes or broadcast the information all our nodes. Then rest of nodes just like Eve and John also update the basis on the global copy. So here Eve also store the Alice or Bob transaction in $100, and John also will store the own block and update the own block and add the own blockchain data. Alice to Bob send the $100. That means Alice we have only wallet is a $100 because $100 sent to the Bob. The next slide we have shown that Alice is own $100, Bob is own $100, and nothing, Eve and John is own $0. So here, Bob in this slide, Bob sent the $50 to the Eve. So all our nodes we have checked. Alice, Eve, John, and Bob. All our nodes have checked the own database on own local copy. Bob is a $50 or not. So here check the all our nodes. Here $100 received from through the Alice. So $50 sent to the Eve. Then after we have successful transaction, we have received the Eve and Eve broadcast the information to all our nodes. Then all our nodes we have add the block on the own local copy based on the global copy. So next we have shown that transaction is new request is initiated. Alice sent $150 to the John. Nodes we have checked own local copy. Alice is $50 or not. So Bob is checked. Alice only rest of amount is at $100, and John also checked own local copy. Alice only received on $100, and Eve also checked there. Alice only own dollar is the own wallet is a 100. But we have initiated the request to the $150. So that means this transaction is a invalid transaction. So the invalid transaction cannot be updated and that can be added in any local copy and not a global copy of the database. So that means here the $150 cannot be added any of local database of Alice, Bob, John, and Eve. Only successful transaction and successful delivery of transaction, any types of data that can be stored in the blockchain. Just here, only just like amount of money can be transferred from one person to another person can be stored, but it can be used any type of transaction. It can be shared just like using of the medical health record, patient's records. So patient records can be updated if the record is very successfully transferred and successfully received all other nodes that can be read and can be stored the own database and own local blockchain. Then after we have update the another global copy through the database. So here we have discussed some replication of the blockchain technology. What is the replication of the blockchain can be used, how to avoid the database, and the blockchain technology can be used of the decentralized network. So that means data replication. So their additional blockchain network employs the data replication, wherein each node a copy of the entire ledger. Each node, that means there are thousands of nodes, and the thousands of nodes can be stored the copy of entire ledger. So this design leads to increase the data redundancy and providing the fault tolerance and ensuring that the data remains available even if some nodes fail. So here the data is replicated all over the application. So give us several advantages in the replication using of the blockchain technology and the DAY-3. So if one of the replica gets corrupted, then the other replica are there to make sure that the integrity of the information contained in the data is maintained. That means there are 10 nodes in the network. Node number 10 is the corrected and lost the information, and anyone can be hacked then we have add the any new add of block in the blockchain, then can be easily identify which node is a malicious node, which node is a loss of the data. Then after we have replicate the whole local copy to the another compared to the node of 10. Just like the node 10 is a lost the old data, all the data, then can be replicate to the node number 9, 5 to 8, and any other we have node we can the database of the local of the node 10. So if the consistency of the data is maintained by a process is a called a consensus. Replication of the data and maintain and updating the blockchain and local database and global database is a using of the consensus mechanism. So consensus is just means is the mechanism by which all users consensus is the mechanism by which all users within a distributed ledger agree on the validity of underlying transaction. That means can be agree on the single value of nodes and single value of decision making. So blockchain use consensus to elect a leader who decide the content of the next block. So that means the leader is responsible for broadcasting the created block to the network. So here consistency of the data is maintained by the process called a consensus. Consensus means that everybody agree that the data that goes into the data structure is that they agree to put there on the and the own local copy of the blockchain. So the consensus algorithm determines which state of the blockchain is chosen to be valid and to based on the voting system. So if it is only when consensus is achieved that the new transaction is recorded into the block and is linked to the already existing chain of blocks using a hash pointer to this block. So in short, it can be said that consensus is mainly achieving the trust of distributed nodes of the multiple domains. So the node in the network require consensus algorithm to achieve an agreement on a single value. If at least 51% of the node reach a consensus that the solution found by the node is a valid, otherwise node is a treated is a invalid. So then that solution is a treated as a valid solution. Then after we have add the block in the own blockchain, then after we have broadcast the information of the block to all other nodes, and all other nodes then receive the node from, information from the leader nodes, then can be update own local blockchain of the data. So to add a new block in the blockchain, so the various consensus algorithm like proof of work, proof of stake, delegated proof of stake, Byzantine fault tolerance, there are lots of consensus algorithm in the market. So here and linking there is a cryptography technique called as a hashing. One block to another block linking using of the hashing of the block. Just like one block is a successfully implemented, successfully transfer and successfully executed, then we have generated the hash. This has been using of the another hash, another block of the hash. Just like we have tracking the information from 10 to 9, 8, 7, 2, and 1. So blockchain has capability to distort the status of third-party brokers and provide the security such as provenance, integrity, privacy, authentication, and confidentiality. So here we just like discussed just distort the status of the third-party broker. So in the traditional banking example, this example we have used, traditional banking is in person banking at an established financial institution such as types of bank, State Bank of India, Bank of Baroda. So these banks have a physical presence and they are made of the local branches in area. So they operate along with the regional and national headquarters of locations. So most of people use these banks to manage their personal account, and these including the checking of the database and check using of check we have retrieved the data and money and the saving of the retirement and more. Beyond the personal account, many people also use them of their businesses operation to the variety of capability these bank offer. And these bank we also governed by the RBI. That means we have transferred the money from one bank to the another bank. So we have some types of charge we have uses just like we have IMPS, IMT, and we have middleware work of the RBI in the banking system. So this type system we have resolved using of the network named Satoshi Nakamoto. So this Bitcoin network is a peer-to-peer payment network that operate on a cryptographical protocol. So user send and receive Bitcoin, the unit of the currency, by broadcasting a digital signed message without any authorities. So to the network use Bitcoin cryptocurrency wallet software. So here that can be resort to the third party broker and provide the integrity, privacy, authentication, and confidentiality of the money and any types of data. So the transparent and immutable of the blockchain help to reduce the need for manual intervention and also mitigate human error arising because of conflict of data. So that means we have blockchain, we use transparency of data and immutability also provided data in the store in the blockchain. Anybody cannot be modify the data, not can be edit the data in the blockchain. And also we have resolved the human error. Just like we have write up and type the write the database in, just like we have any student information stored on the database. We have some information we are using of Aadhaar card. We have write the name and roll number and section. Again, some typological error can be stored in the some other types of information, wrong information can be stored in the database. But if using of the blockchain, so transparency maintained and using of the consensus algorithm can be reduced to the human error arising and also conflict of the database. So here we have discussed some example of the consensus algorithm, just like example is the Byzantine general problem. So Byzantine general problem is an example of the consensus algorithm. So here each division of blockchain army are directed by its own generals. So generals, some of which are credited and communicate with each other by the managers. So requirements, all generals decided upon the same plan of action. Some number of trader can cause the loyal general to adopt the bad plan. So here we have discussed some example in the using of Byzantine fault tolerance. In this figure, we have shown that one commander and there are three lieutenant 1, 2, and 3. Commander send the V message to the all our lieutenant, and here all lieutenant we receive the information from through the commander. So lieutenant 1 we receive the V message to the commander, and lieutenant 2 also receive the message of V through the commander, and lieutenant 3 also receive the V message to the commander, and lieutenant 1 send the V message to the lieutenant 2, and here lieutenant 3 send the X message to the lieutenant 2. So lieutenant 3 is a territory, is a lieutenant 2 is a point of view, because here lieutenant 2 receive the two message of V is a one message is a commander and one message lieutenant 1, but here one message X is received through the lieutenant 3. So basis of voting we have achieved the 51% of note There, point of view of Lieutenant 2 is Lieutenant 3 is the territorial. Lieutenant Commander is a territorial. So whole system is a territorial because the commander of is also is a territorial. So the whole system is a territorial. So there are some problem and finding solution we have used in the Byzantine fault tolerance. So any general has got receive an official message from attack. So that it means that the general would not attack. Therefore, general can wait a specific period of time and wait to receive the message from the attacker. General means they are a commander. We have received the information from the any types of information we have received through the commander. The commander we have wait the information of the find of the message. So if any commander has not received an official message for attack, so then it means that the general would not attack, not attack. So therefore, general can wait for a specific period of time and wait for receiving the information for the attack. If the period passes and they do not receive for attack, they can retreat to the camp. So general commander could also ask for secret messages from messenger as a Byzantine general problem solution. So the secret message must be known only to the commander for verifying the messages. So in addition, the general could also ask for the official seal of the other and other lieutenant for verifying that the other lieutenant actually passed the same information or not. So you could also think of variation or to the Byzantine general problem, example in which horsemen from each general would ride toward the city as an indicate of a track. In such case, the general can agree on a condition if there out of three lieutenant and five lieutenant, four lieutenant have raised the banners. So the increased number of messages could improve the chance of the message reaching to the commander. So the loyal commander would follow the order, agree upon the invest and necessary effort in execution of the plan. So if commander share the information to the general, lieutenant receive the message, the outcome of the potential of messages. So in case of more loyal lieutenant for carrying out of order, you can accept better outcome easily. So this is a basic example of the consensus algorithm, the Byzantine general problem. So the analysis of the algorithm, that means there are three steps in the network and any algorithm can be reach the agreement of the value, any consensus algorithm. Step is a elect, second step is a vote, and third step is a decide. So in a step one is a elect, that means all node elect a single process term as a leader is a make decision. In the previous figure, we have leader is a commander. The leader proposes the next valid output. So the figure just like show that commander we have decided the next output value of the messages we send to the lieutenant. So step 2 is a vote. So the non-faulty processes listen to the value being proposed by the leader and validate it and propose it is the next valid value. So here non-faulty node means is a commander, sorry, lieutenant is a non-faulty node and the leader is a commander. So the non-faulty process listen to the value being by the proposed by the commander and validated it propose it as the next valid value and next is a decide. So the non-faulty there are non-faulty nodes and the processes must come to a consensus on a single correct output value. We have left to have single correct output value is a V. So if the leader receive a threshold number of identical votes for an output value that satisfy certain criteria, then the processes will decide on that value. Otherwise, the all are step again and all are over again. So in analysis of any consensus silk or some any proof of stake delegated authority Byzantine critical Byzantine, so we have three steps can be followed: elect, vote, and decide. So here we have discussed the basic definition of the blockchain. So blockchain is an open distributed ledger that can record transaction between two parties efficiently and in verifiable and permanent manner. This is a basic definition of the blockchain. This is a standard definition of the blockchain technology. And previous discussed blockchain technology definition just like only understand how to decentralized network, relational making, information sharing platform, and rational decision making process can be discussed in the previous slides. So in this definition, they are open, distributed, efficient, verifiable, consensus, and permanent. So open means all our information is accessible to all our nodes, all our machines. And distributed means no single part of control. That means one coordinator is a field, then another coordinator can be connected to the field coordinator peers nodes. And the efficient means fast and scalable. And verifiable means everyone can check the validity of information. Can be whether is valid or not. In consensus, agreement on a single value. I have already discussed the consensus algorithm, and example we have also discussed the Byzantine fault tolerance. We have achieved the single decision of receiving of the votes and the basis of the messages. And the permanent means information entered in a blockchain in persistent or tamper proof cannot be updated in the future. The committed transaction can never be rolled back. If the transaction, if the block is added in the blockchain, nobody can be updated and nobody can be modified and deleted. Nobody can be rolled back to the transaction in the store of if the data is added in the blockchain of the local copy, another is a global copy. So here we have discussed some traditional data differentiate between the blockchain technology. So database use the centralized storage of data, and blockchain we use of the decentralized storage of the data. Database need a database admin or database administrator to manage the stored record, but in the blockchain there is no admin in the manage the database because it's a distributed way of nature. Modifying the data in the traditional database, modifying the data require permission from the database admin. If the data can be changed and modified and deleted, it can be used of admin, can be any types of operation can be performed in the traditional database. But in the blockchain, modifying data does not require permission. User have a copy of the data and modifying the copy does not affect the master copy of the data because blockchain is irreplaceable to modification of the data. So if anybody, any nodes can be updated and modify, trying to modify and delete the data, then the data cannot be updated in the master copy of the blockchain. So centralized database keep information that is up to data at a particular moment. But in the blockchain keep the present information as well as the past information that has been stored before. Nobody can be changed in the data. So the traditional database are used as a database for a really long time and have a good performance. But in the blockchain technology is ideal for a transaction platform, but it's slow as a centralized database because centralized database can not be used in the consensus process and decentralized process. So here blockchain technology we use is the consensus algorithm and can be verify the data, and then after we have add the own local copy, then after we have transfer the data, sorry, broadcast the data all other nodes, and all other nodes we have update the data in the own copy of the database. So here we have discussed the working of the blockchain based transaction. So in this figure, we have show that there are two persons, Bob and Robert. So sorry. So here Bob, some transaction we have transferred any types of data and money can be transferred to the Robert. The transaction from Bob to the Robert. So here add transition to the block. So in the block is a lots of transaction and lots of transition in the single block. So the number of transition in the block 1, 2, 3 and n. Then we have after some time of block is a full in block nobody and another transaction can be added in the block because the blockchain is a 8 MB only of data can be stored in the block. So the can block is a full, then can after we have broadcast the block to the all other nodes. So all other nodes, we just like we have a network in the nodes in the thousands of node in the network that can be broadcast to the network block of thousands of node. In thousands of node, we have received the block of the transferring from the broadcasting the block to the platform. So here we have broadcast block to the network. So here there are lots of miner in the blockchain network, miner 1, miner 2 and miner n. And then we have mining the and can solve the computational puzzle problem using of the high computation power of computers can be solve the hash problems. And then we have in this algorithm in this figures we have discussed the proof of work processing power that can be solve the mathematical puzzle. So if the miner 1, 2, 3 and any one miner can solve the data using of the broadcasting of the block of the network. So here in this figure, miner n solve the proof of work solution and find the computational puzzle problem. So other miner, then after we have miner n solve the computational power, computational puzzle. Then after we have broadcast the result to all other nodes. Then all other nodes we have received the message and received the solution through the miner n. Then all our nodes we have checked the validity of the proof of solution, proof of work solution. If miner n is solve the valid computational puzzle or not. So if here node n we have solved the valid problem, valid solution, then blockchain network nodes validate the block. And then after we have received the 51% of node to the leader, it can be added to the block, the own local chain, and then after can be broadcast the all our network. It can all our nodes also adding the block to the chain. So that is a basic formal working or the blockchain based transaction. Any types of data can be transferred from one node to the another nodes. So a step involved in a blockchain based transaction. So here a transaction is requested and authenticated. So block representing the transaction is created. So first we have block is created, then after the block is set to the every node in the network. Just like 10 nodes in the network, node 1 is initiated the block and representing the block and complete the all our transaction in the block, and all our rest of fields we have updated in the blockchain. Then after all our condition, we have all our condition is satisfied and fulfilled. Then after we have brought node number 5 block is sent to the every node in the network. With all our nodes, we have solved the computational puzzles problem using of the consensus algorithm. So in this figure, we have shown that nodes, all our nodes, they validate the transaction. So if the node 2 is a solve the computational puzzles problem is first, so node 2 is a receive the reward and the incentive using of the Bitcoin in the term of the some Bitcoin. So currently, just like we have solved the puzzles problem in the Bitcoin, so we have received 0.006 Bitcoin to the solver. So we have node to receive the reward for the proof of work. So the block is added to the current blockchain. Then after we have broadcast the block to all other network. So the updated is a distributed across the network in the node. Then after we have transaction is completed. So this is the basic steps involved in the blockchain based transaction system. So here, generation in the blockchain technology. So the first generation is the 2008 to 13. So the origin of the Bitcoin. So proposed by Satoshi Nakamoto. So there is a limitation and disadvantage of proposed method of first generation of the blockchain and Bitcoin. So only based on the money transaction, and they cannot be used on the assets and any types of another information can be shared using of these uh, properties. And then second is a second generation to 13 to 15. So the transaction with smart contract Ethereum. So introduce the programmable contract named smart contract, which can be checked by all the participants focused on the assets or shares. So user can exchange the numerous types of assets, including properties, boards, and goods. And the third generation is a 2015 to 2018 is a distributed application app. So compiling the both involved parties to follow the correct smart contract strictly. So significant enhance the blockchain capability, leading to its worldwide popularity. So last currently is the fourth generation, 2018 to current time. So many governments and organizations are investing heavily in the innovation and application in the blockchain technology. So here discuss is a blockchain. Blockchain is a append-only distributed ledger where records are stored in hash-linked block, and these blocks form a chain. So it combines several computer technologies, namely distributed data storage, consensus mechanics, encryption algorithms, and asymmetric cryptography. Distributed consensus algorithms have been implemented for user security and ledger consistency. So it works in such a way that no transaction can be modified when the block is published. So the in this block, their first block is always called as a Genesis block. Then in this block where there are some fields, block name one nonce value you can find using other proof of work consensus algorithm, and the other transition of data and previous has block is just like a Genesis block. So where cryptography has secured this link is called cryptography hashes of link. So cryptography has secured the link from the block to predecessor. So it is a growing list of record is called block which are linked using cryptography of hash. So there is a here is a block structure in a blockchain. So a block chain is a made up of block, each of which is linked to the one before it, creating the skeleton of the entire blockchain. So a block is a data structure that contains a collection of transactions before submitting them to the blockchain for verification. So here in this slide we have shown that a block is a blockchain is a structure that batches multiple transactions at a suitable size of block. A block consists of two components that are block header and some data is shown in the figure. So every block is a collection of verified data stored in the form of the Merkle tree. There are some blockchain block feature, just like it is the place where information is stored and in the blockchain. So it includes encrypted information, encrypted transaction information from previous block and a new transaction information. So every new block created contain a reference to the present parent block and they create the chain. So the data within a block must be verified by the network new block can be added. Network means it can be verified through the consensus algorithm. A completed block is a permanent record of prior transaction and new ones. The first block with no previous hash is called a genesis block. So the consensus mechanism is responsible to verify a transaction and adding a new block to the blockchain. The using of the hashing, what is the advantages we have used in the hashing? That means the blockchain block as a hash in itself, it can accept as a unique fingerprint for each block. So this help identify a block and it contain which is always unique as a fingerprint. So as the block is created, changes inside the block will cause hash to the chain. Therefore, the hash play a significant role for you to detect the change to intersection of the block. So if your blockchain fingerprint change, it no longer stay the same block. So it can be said that each block has it's like data has as the previous block unique hashing parameter. So the hash algorithm used in a blockchain has a specific unique property. These properties are just like the blockchain, the technology is designed to produce a unique output or hash for every transaction. So these hash used in the blockchain are one-way hash function that cannot be reversed and altered. The blockchain uses the cryptography as function property as its consensus mechanism. The cryptography has act as a digest and digital fingerprint for the definite quantity of data. In the blockchain, cryptography has function. The transaction is accepted as an input and spent through a hash algorithm. So and give a output of the fixed size using of the any types of hash 128 and 256 and 1512. So here we have discussed the core component of blockchain. So here create a secure digital wallet and private key that can generate a digital signature and public key can represent the pseudonymy of user addresses. That means it's a asymmetric cryptography can use of the public private cryptography technique. So here a transaction, the group of transaction from blocks and represent of current state of blockchain and conversation of the value is must. And the consensus mechanism, common agreement of protocol and validate the block, update the ledger, block miners and the incentive. And then after we have secure the distributed ledger blockchain. Use of cryptography, initialization of broadcasting of the transaction And after digital signature, we using of the public and private key. Then the validation and verification of the transaction, then using of the proof of work, proof of stake, and other consensus mechanism. And then after we have chaining of the block and add the block to the existing chain of the block, we using of the function. So there are some key characteristics of the blockchain: immutability, decentralization, consensus driven, and distributed data control, accountability, reliability, transparency, trust, and reduced transaction cost. Recording rights of data through the blockchain will help in annual cost saving and provide a tamper-proof ledger with the benefit of such as, just like here, show that immutability, decentralized, consensus, reliability, and all things. So immutability means blockchain technology ensure that once and data is created, the block is it cannot be modified under any condition. All the data is distributed in secure public ledger. Then decentralization means distributed ledger is a decentralized digital ledger for storing transactions or any other consistently and securely information. And then consensus driven means a consensus is a dynamic way of reaching to an agreement on a single data value among the distributed node. And then distributed data control means any changes to data stored on the ledger are reflected simultaneously to all other participant node of the ledger. Then reliability, any relevant changes in record is possible only if there is no consensus process. So which is not true in the case of the distributed ledger technology and blockchain technology. If consensus is if the consensus is not used, that means only distributed network, not a DLT based network. So because consensus in blockchain is a nothing. So which is not true in this case. Transparency, blockchain help in maintaining irreversible record of transaction event in sequential order, which bring more transparency in businesses transactions. Every registry offices has entire blockchain of transaction and holds a history of the transaction that can be accessed anytime from anywhere in the blockchain system because a decentralized network. And the trust, blockchain based data application shall ensure that people will start using it with more social inclusion. And the last, reduce cost. So blockchain technology gives an opportunity to market participant to directly access decentralized asset and store information. They are key characteristics of the blockchain technologies. So here we have discussed two types of blockchain basically, but blockchain is a third type of blockchain is a hybrid, that is consortium blockchain. So there are two types of blockchain architectures, namely public blockchain and private blockchain. In this table, we have show that the comparison between the public and private blockchain. So public means a public blockchain, also known as unpermission or permissionless blockchain. That means anybody can be create the account and contain the information of the existing blockchain and update the old replica of the copy. So blockchain allow anyone to participate in the blockchain to create and to validate the block. Next is a private blockchain, means a blockchain, a private also known as the permission blockchain, allow only authorized and trusted entity to participate in the activity within the network. So here we have shown that some comparison between the public and private. Public blockchain is a centralized node, but private blockchain is centralized because we have more number of stake we have in any nodes that can be more powerful of the mining of the process. It's like any education system, the director, we have whole power, can be any types of decision can be taken by the director. Nobody can be change the decision of the director. So here permissions to read in the public blockchain, private blockchain, it could be public or private based on the problem. Immutability almost impossible to tamper because it's a public blockchain, and possible be tampered because a private blockchain can be one person can be more powerful, and a consensus determination all minor and one organization. Efficient, quick, low is superior because one organization, not a public, is a private blockchain. And consensus process, public blockchain is a permissionless blockchain. Nobody can permission to enter the blockchain. And private blockchain is the permission blockchain. Only authorized person can be accessed in the blockchain, for access the information. So here the classification of the blockchain of permission based. So permission blockchain, it permit any nodes having a valid pseudonymy, means account addresses, to join and quit the network without any authorization. Node can use the common node to receive, send and validate the block. Example, Bitcoin, Ethereum, Solana, and permission blockchain prior to participate in the network operations. Permission blockchain require proper authorization of the participant. So the effective network governance and identity revealing requirement is permission blockchain, make it ideal for multi-party or internal business applications. And next is a participant based blockchain, that means public blockchain. The participant can engage in the consensus process by reading and submitting the transaction if they are valid. A set of transactions are broadcast by every node, and few specialized node called miner called them to verify the validity. Example, Bitcoin, Ethereum. And custodian blockchain means a predefined set of nodes control the consensus process. That means they are partially private and operate under a group of leadership instead of a single leader. So example, just like a hyperledger can be launched by the IBM. And the private blockchain keep the read permission public and write permission centralized to the single organization. And only entity in the private blockchain rule the entire system. So the basic difference between the public, private, and custodian blockchain. So here we have some blockchain platform for the technologies can be used. So there are some leading technology platform are like Ethereum, Hyperledger Fabric, Hyperledger Satur, and interplanetary file system discussed in this structure. So first we have discussed Ethereum. Ethereum is an open source, globally decentralized computing infrastructure that execute program called a smart contract. So smart contracts are simply programs stored on a blockchain that run when predetermined conditions are met. That is a smart contract. Ethereum provides a blockchain to synchronize and store the system state, and along with a cryptocurrency called ether to pay the execution cost to the miner in the term of the ether gas. Gas is a unit that measures the amount of computational effort that it will take to execute certain operation. Every single operation that take part in Ethereum, be it a transaction or a smart contract execution, require some amount of gas. That means ether can be required for validating and verifying the transaction in the Ethereum. So is a fee of the royalty from the validating the transaction of any machines. Any transaction can be verified, pay the some amount of money in the Ethereum. Next is a Hyperledger Fabric. Hyperledger Fabric is the first major private DLT system. Is originated from the Hyperledger ecosystem. So it has been designed with strong privacy in mind to ensure that different governmental agencies and businesses organizations can take advantage of DLT system in different use cases. So that means a crucial capability of Fabric is that it can maintain the multiple ledger within its ecosystem. So it is a useful feature that which separate Fabric from the DLT system and consisting of only one ledger in each of other domain. So currently, Hyperledger Fabric support Solo and Kafka consensus algorithm. And SBFT means simplified Byzantine fault tolerance algorithm is to be released soon by the IBM using of the Hyperledger. So Hyperledger Fabric is not a decentralized network. Most of the either is a single organization control it a group with a shared responsible. Next is Hyperledger Sutu. So in this platform, initially developed by the Intel, is a software program and software framework. So for creating a distributed ledger suitable for variety of use cases. So Sutooth utilize a novel consensus algorithm is a called proof of elapsed time, and which depend on Intel SGX. Intel SGX means software guard extension. So mainly depend on the SGS. So Intel XGS is a trusted execution environment. So integrated into Intel new generation process. So SGS enable the execution of code within a secure enclave inside the process. Validity can be verified using a remote attention and a process of SGX. So the major drawback of this Sutooth protocol, it is dependency on the tested education environment enabled hardware. The last is IPFS. IPFS means interplanetary file system. It is a decentralized storage system that enable the storage, access, and security of file over a distributed file system. So cryptography is a created for every file. The file are stored in a node. So whose indexing is done such as each file can be accessed through the node. So there are certain advantages of using the IPFS in the comparison of the other available platform. So it follow a peer-to-peer architecture that provide a decentralized way for the storage and retrieval of file. So it is a distributed version file system that allow different kind of application to be built on top of it. So using the IPFS with blockchain, we only need to store the hash of the IPFS file on blockchain. So while allowing the user to exploit the file storage and peer-to-peer property of the IPFS. So it also provides data distribution protocol, a routing system to find the peer addresses of other peer. So and all other function and the blockchain is application required. So in this platform technology, IPFS is an open source platform. It is not required to pay a royalty of transaction confirmation. So blockchain is a we use here the no royalty can be paid using of the IPFS. There are some royalty paid in the Ethereum and Hyperledger and SO2 is just like private blockchain can be used. So need for the consensus. So why we need the consensus? That means a consensus mechanism is a fault tolerant mechanism that is used in a computer and blockchain to achieve the necessary agreement on a single data value or single state of the node among the distributed ledger. So the consensus mechanism is a process to achieve agreement on single data value. The consistency in the distributed ledger means all node must have the same image of the ledger at the same time, which can only be built by using a consensus mechanism. So consistency and the consensus mechanism. So the consensus algorithm determine which state of the blockchain is chosen to be valid and true. It is only when consensus is achieved that the new transaction is recorded into the block and is linked to the already existing chain of blocks using a hash pointer to the previous block. In short, it can be said that consensus is mainly achieving the trust of distributed nodes. The nodes require a consensus algorithm to achieve an agreement on a single value. So here we have discussed there are types of consensus mechanisms. There are some leading consensus are like proof of work, proof of stake, delegated proof of stake, proof of elapsed time, proof of readability, practical Byzantine fault tolerant, and tangle. So most powerful and most famous consensus algorithm is a proof of work. It is used in a Bitcoin network. Proof of work is a proof-based consensus algorithm. Proof of work is a incentive consensus method where nodes are rewarded for creating new blocks and adding these to the chain. A miner must solve a cryptographic puzzle to add a block to the blockchain. In this case, the miners are paid incentive when the puzzle is solved and therefore make use to high-end computational expensive devices to be the first to solve the puzzle. And next is a proof of stake, is a consensus algorithm that work on the idea that node who wish to participate in the consensus process must invest some stake in the network. These stakes act as a guarantee that the node will not causes any harm to the system. A recently discovered limitation of the consensus algorithm is called the nothing at stake problem. So nothing at stake is a security issue in the proof of stake consensus algorithm. The next is a delegated proof of stake. Is a DPoS is an elective consensus procedure where each node with a stake in the network can elect the leader by the process of voting for transaction validation. So inside the blockchain, it is also referred to the since different stakeholders vote for the block leader who will validate the transaction on of behalf of the other nodes. That's the Indian democracy system. We can be MP elect by the public by using of the voting system. Then after we have elect the MP and MLA, that can be select the chief minister and the prime minister of the Indian government and state government. It is based on the delegated proof of stake. Then another is a Byzantine fault tolerance. So BFT is refer to reaching a consensus between two or more number of nodes in communicating safely occur across a distributed network in the presence of malicious or misleading node. So during consensus, all participants send their decision to a leader. If every node send the some decision and the leader check the and agree the malicious nodes on that or not. And then the next is a proof of elapsed time, POET, is a form of a proof of work consensus algorithm where proof of work is replaced by wait time for the node to assume role of leader that is randomly generated by a trusted execution environment system. And the proof of retrievability and the POR was originally proposed by Julius in 2007, the semi-trusted distributed achieving system. So the core feature of POR is to allow a file owner to check if it is online file or file fragment are securely stored and retrievable through the challenge response protocol. And the last is a Tangle. Tangle is considered to an evaluation of the blockchain belonging to the distributed ledger technology. And Tangle is a blockless blockchain. It is based on the directed acyclic graph, a finite directed graph with no directed cycle. Here we have shown that some comparison of the consensus algorithm. So proof of work, proof of stake, delegated, PBFT, POET, and POR, and IoT. So there are some main features: fault tolerance, power consumption, and scalability. So here, main feature of the proof of work is the computational power required to solve the computation power. But fault tolerance is very low, and power consumption is very high, and scalability is high. Proof of stake is based on the amount of coin. The number of nodes in the network. There are 20 nodes in the network. Node 15 is a more powerful, a more amount of coin will stake. So that can be powerful for the decision making process. So that can be just like a centralized system. The fault tolerance is equal to the 51% low consumption and scalability is high. And delegated we based on the voting to elect the witness node, just like giving example of India. And proof of elapsed time is based on a lottery-based election process. And scalability doesn't scale well because of tested education-based system. And proof of readability is a use of time stamp of transaction to verify existing of the document. And IoT consensus based on the using of the IoT-based application of the blockchain. The fault tolerance is not acceptable, scalability is high. So there is a growth of the blockchain technology. So amount of global technology in the global blockchain market is accepted to be worth of in 2025 is a 24 billion. The bank currently experimenting with the blockchain technology 20%, and the banker accepting commercialize the blockchain adoption next year is a 40%. The number of blockchain related in the LinkedIn job posting more than tripled over the last year. In the current times, just like a layoff of the some top companies, but in the more higher in the job seeker in the blockchain based companies. So just like 20 in the market, so you're only 5 to 6 developer in the blockchain in the market. So reported potentially annual saving for bank utilizing blockchain technology around 8 to 12 billion. And ICO investment increased 16 times in compared to the last year. And Ethereum grew 50 times. And real time and real estate industry is a contribution is a massive that support about 8% in India. So there are some blockchain use cases in the distributed technology and real world cases. Healthcare management, banking sector, insurance management, land related management system in the real estate industry, supply chain management, agriculture, voting, and recently very emerging topic of the research, electric vehicle charging decentralized system and trading of electricity in air to air, and also we have internet of vehicle we using of the blockchain technology, a very trending topic in the market. So here we have concluded the slides and our presentation. So technology advances of internet enable world competition for secure resources and increase social challenges and accelerate the information to data-driven worlds. So in a such system, a centralized authorization and authentication and access model force the end users to trust a third party for processing the handling and managing their IoT, cloud, ML, and AI data. In such an ecosystem, blockchain can offer a platform for sharing information of the data. Thank you.
Thank you, sir. Dear participants, if you had any queries, you can proceed now.
Dear participants, if you have any queries, you can just unmute yourself and ask your queries. Otherwise, you can just type your queries into the chat box. Dear participants, that is very queries. If you have any questions, You can
Ma'am, it seems there are no questions.
Hello.
okay, ma'am. We'll be concluding with the thanks for them. So thank you so much, sir. On behalf of all the organizing team, I would like to say thank you for sharing your knowledge and expertise with us. Your presentation was very insightful and provided us with a lot of valuable information on blockchain, consonance mechanism, the growth of blockchain market and its blockchain. I hope you enjoyed your session and found it beneficial as well. We are looking forward to you see in future events, sir. Thank you once again, sir.
Thank you, ma'am.
Over to Shanti, ma'am.
Thank you, ma'am. Thank you, Dr. Yadav, for sharing insights of blockchain technology and security attacks. Looking forward to. Hello, am I audible?
Yes, audible.
Yeah, sir. Looking forward to having you again and in our future events also. Thank you so much, sir.
Thank you, ma'am. I can leave it.
Yes, sir. A very good evening, participants. I, Dr. Shanti Makka, and I would like to thank each and everyone for taking the time of your day to grace us with your presence. I hope you are doing great and reflecting upon your learning during the workshop. Tomorrow we have Dr. Rajesh Kumar Kaushal from Chitkara University, Punjab, who is going to deliver a session on blockchain technology, its functioning and pathway of using Hyperledger Fabric framework. And this session would be completely hands-on. And thank you all. Have a great evening. Bye.
Ma'am,
Thank you,
we'll take
ma'am.
a photo session, ma'am.
Many of the people have left. Yeah, you can. Participants, please kindly switch on the camera so that we can take one or two screenshots, please. Sir, please, you also, sir.
Yes, sure, ma'am.
Participants, please turn on your cameras, please. Students, please. Cindy ma'am, please take screenshots, please.
Yeah, ma'am. If that presentation is turned off so that.
Hello, madam.
Hello,
Hello.
madam. But camera is not enabled.
Hello.
Okay.
Madam, this
Yeah,
session PPTs are today's session PPT shared in group, madam.
yes, sir.
PPT.
I'll just make a request to sir.
Okay. Today's session's PPT.
Sure, sir. I'll make an arrangement and I'll just keep it in our group itself, sir. WhatsApp group.
Okay. Today, tomorrow. Okay.
Is it done? Can we close?
Yeah, ma'am, it's done. We can close.
Thank you so much, sir.
Thank you, madam.
Thanks.
Thank you very much, sir.
So we can close the session, sir.
Okay, madam.
Okay, ma'am. We'll end the session.